Hi everyone, and welcome to the Unit 5 Family video for 2nd grade math. I'm your host, Stephanie Conlin. I'm an elementary math curriculum specialist here in CMS in the Learning and Teaching Department. I'm glad that you could join me today. We're going to focus on Unit 5, which is thinking about numbers to 1,000. This work starts in quarter 2 for 2nd graders and it wraps up in quarter 3. By the end of this video, I hope that you have answers to these 3 questions. What is your child learning in this quarter as it relates to numbers to 1,000? What does that look like, and what can you do at home to help? So numbers to 1,000. We introduce students to a tool called Base 10 Blocks in this unit that really helps students understand how big numbers are. We can build numbers out of Base 10 Blocks by determining how many hundreds blocks, how many tens blocks, and how many ones blocks we need to represent a number. Maybe a visual of that would be helpful. So I could build a number using the base 10 blocks that we see above by making a couple of hundreds, a couple of tens, and a couple of ones. So students begin by looking at the large square base 10 block and thinking about how much that is worth. And if they're trying to represent a number, one way to do that using the base 10 blocks is to determine how many hundreds, how many tens, and how many ones you might need from your base 10 blocks to represent that number. This work is really helpful for students when they start to learn how to represent numbers different ways. You might remember the phrase expanded form from your math classes in the past, and that's one way to write a number that uses place value. So you might have already noticed that we're talking about hundreds, tens, and ones in this video, and that we use those place values when we describe a number. So students really analyze a number with 3 digits up to 1,000 using base 10 blocks, expanded form, and sometimes we use drawings of base 10 blocks because it's just a little more efficient. So you might notice that students like to use the tools at first, and then we transition them to a drawing of the base 10 blocks in order to help them become more efficient problem solvers. And that expanded form can come through from this picture as well. I can still pay attention to how many hundreds, tens, and ones that I have. One problem that 2nd graders are going to encounter is how do you decide how much you see when the number of hundreds, tens, and ones goes past 10? In other words, how much is this? I see 2 hundreds and 11 tens and 12 ones. So exactly how much is this? Students learn that when we express an amount like this, that we can call that an expression. And what we want students to consider is if they can join some of these tens together to make another 100, and can they join some of those ones together to make a 10? And until they do that, it's really difficult for them to say exactly how much is here. So when we join our tens together to make 100, and we join our ones together to make a new 10, then we can see that this is actually 322. So it's a little more difficult to see from this original picture, but we help students see that they can group some of those tens together. When they do that, then it's easier to name how much they have. Here's another example of ways that students learn to represent numbers. This is called word form. It's how I would say the number using words. And so we teach students how to write numbers in word form as well. In the later part of Unit 5, students learned that the numbers that go through 1,000 can also be represented and found on a number line, and we can solve problems using the number line. So here's an example of some work students will encounter in this unit. They'll be asked to estimate the location of 2 different numbers on a number line. Notice that both of these numbers have a 3 on the hundreds place. So students really have to think about how many tens are in the number and how many ones are in the number in order to mark them with a point on the number line. And then use their symbols to compare the 2 numbers. So as you can see in this example here, we want students to think about which number is farther to the right on the number line because they've already learned in the past that the larger numbers are farther to the right. As for something that you can try at home, we're going to go over 4 different tasks, all using the same number, 593. Now, don't feel like you've got to do all of these in one night or one sitting. It might be fine to just do each of them on a different sheet of paper or all on the same sheet of paper and look at all the different strategies that your child has learned throughout this unit. So we're going to start by writing the number 593 as a number name and write it and write it, in expanded form. So the number name for this number is 500, 90-3. Now we're not going to get too hung up here on the comma and the dash, but just so you know that conventionally that's how we would say this as a number name. And in expanded form, we're showing this as a sum of 500s, 9 10s, which is 90, and 3 1s. Now the next job that we have is to draw a picture of it using base 10 the base 10 drawings. So we still see 500s, 9 10s, which make me a little cross-eyed when I look at it, and 3 1s. So we've got our 5 squares, which represent hundreds, and each of these long ones represents a 10, and we have 3 1s here. This is like a visual of the expanded form. So these pictures we should still see 590 and 3. So next is to create a number line from 500 to 600 and place the number 593 on the number line. Now a little hint here, I decided to find all the numbers between 500 and 600 that change in the tens place. So I was counting by tens. So notice here that I thought, okay, I'm going to go 510, 520, 30, 40, and this is the work in the unit as well. So we start with those numbers to make sense of which side the number would be on. Is it closer to 500 or 600? And then when I got to 590, paying attention to how many hundreds and then how many tens I had, then I counted by ones to help me find 593. And it's between 590 and 600. So for the last part, we're going to compare 593 to 539. Now notice those have the same digits, but some of those digits are switched. They both have the same number of hundreds, so then we should be comparing the tens. So I did that actually using the number line because I had already found 593 over here. So then I thought, okay, 539 has 3 tens, so it's somewhere between 530 and 540. So again, I counted by ones to find that number. Students could also draw 539 using their base 10 blocks and compare it to 593, which is something they may have already done alongside you. But now I know that 593 is greater than 539, and I know that because it's farther to the right on the number line. It's closer to 600 than 539 is. I always like to suggest taking a screenshot here of the tasks and some questions you might ask, some of the solutions here. And here's a really good explanation for what we'd want to hear students say when they are comparing, that they're looking at that tens place, which is kind of like what we had just talked about. Thank you, families, for joining us for our mathematics family video, and thanks for partnering with us at home. We're confident that with your encouragement and support, our young mathematicians will gain a wealth of knowledge and develop a strong foundation in math this year. And for more elementary math resources, you can visit the CMS website. Thanks and have a great year.